All right, for today's deep dive, we're getting into environmental security. And we're going to be focusing on a really specific piece of hardware. It's the NTI E-LD-SPDT-P spot liquid detector.
That's right. And it sounds niche, but think about it. We always hear about these huge, complex cyber threats.
Mhm.
But for a data center or any critical facility, sometimes the biggest threat is just water, a simple leak. So we're looking at how this one small device becomes a critical defense against, catastrophic flooding.
Okay, so let's get right to it. The core function is, well, it detects water. Sounds simple. But why this one? What makes this a specialized, dependable piece of gear instead of just a basic sensor?
Right, and that comes down to the engineering. It's all about resilience. This thing uses microchip technology and, this is the key part, gold-plated probes.
Gold-plated. Why is that so important?
Because we're not just talking about a puddle, it's about reliably detecting conductive liquids over years and years. The gold prevents corrosion, it resists chemicals. I mean, you need to know this thing is going to work on day 1 and on day 3,000.
And a failure could cost millions.
Exactly. Millions in downtime, lost data. It's a huge deal.
That makes a lot of sense.
Yeah.
So that's why it's always mentioned for those tricky spots, like under a raised computer floor or in an AC drip pan.
That's the classic use case. Think about a massive server farm. The cooling infrastructure is incredible. You have chilled water pipes running all over the place.
Right above all the servers?
Right above everything. So placing these detectors strategically in those spots, that's how you build a resilient facility. It's the architecture of prevention, really.
You mentioned strategy. One detail that jumped out at me was the customization. The probe height is adjustable from 0 to 1.5 inches. Why is that tiny range so vital?
That flexibility is everything. It lets you fine-tune the detection threshold. You might want an immediate alarm from the very first drop.
So you set it to 0.
You set it to 0. Or you might want to let it pool just a little bit to avoid, nuisance alerts from condensation. That's the 1.5-inch setting. It lets you match the sensor to your actual risk tolerance.
And it's built to last in those spots, right? I saw it has a cast aluminum weatherproof enclosure.
Oh, yeah. It has to be tough. These things sit in dusty, humid, challenging places for years. That ruggedness is non-negotiable.
Okay, so the device is tough and it's precise. But how does this little sentinel actually report back, especially in a huge facility?
That's the integration piece, and it's really clever. It provides what are called SPDT alarm contacts.
SPDT.
It stands for single pole, double throw. But what it means, basically, is that the detector can do 2 things at once. It can send one signal to the main control room's monitoring system.
For logging and automated alerts.
Right. And at the same time, it can trigger something locally. A siren, a flashing light, maybe even shut down a specific pump. You get an immediate local response and the central alert.
And that's key for cutting down response time.
Right.
But what if that central system is, on the other side of the building?
Not a problem. And that's another big design feature. The maximum cable length on this is 1,000 feet.
Wow, okay.
Over 300 meters, so you can deploy these all over a massive campus. It's also really flexible with power, runs on almost any low-voltage system you'll find in a facility. Plus, you get that simple, clear visual check. Green light for power, red light for water.
So in the end, it really shows that true preparedness isn't always some fancy software. It's about having these detailed early warning systems right where you need them.
Absolutely. It proves that you need that granular monitoring in every sensitive area. Preparedness starts the second a threat is sensed, long before it becomes a disaster.
So here's a final thought for you to take away. Think about the incredible complexity of a modern data center or an industrial control room. How does the simple, elegant engineering of a $285 spot detector with its gold probes and adjustable height act as this crucial hidden line of defense? And what other simple, unassuming devices like this might be holding our critical infrastructure together right now?